Hi everyone, this is the lesson for Tuesday, March 24th. And today's lesson is what is exponential regression. Now, we've done linear regression before, and you should remember that. We did it on the calculator. That's when you do that stat edit, and then you do stat calc and linreg. And linear regression, if you recall, measures how close a scatter plot is to actually a line, which is what the zoo now is based on. So I do believe I'm going to make this lesson into two videos, because if I make it one video, it's too large to upload, and then it's going to be problematic with you playing it. And you do need to have a calculator. The calculator app that I told you to download actually blocks out doing exponential regression. It's like a paid feature, which is why I sent you that link on Google Classroom to download if you have a computer, the TI-84 mirror from Texas Instrument. It mirrors onto your screen. Okay, so I'm going to read you the do now. I'm going to ask you to pause the video, give yourself a few minutes to think about it, and really think about it. See if you can figure out what the answer would be. And you're going to explain your answer using full sentences. Okay? So the do now says the relationship between T, a student's test scores, and D, the student's success in college, is modeled by the equation D equals 4800 T plus 75 and 2/10. Based on this linear regression model, the correlation coefficient could be, and as you're reading this, I hope you're doing what we always do. You're underlining those keywords and phrases. And the keywords and phrases you should be looking at, I would hope you'd catch, would be that correlation coefficient. So see if you can remember what that correlation coefficient is, and that will help you come up with your answer. So please pause the video now and see if you can figure out the answer to this question. Okay, everybody, hopefully you've paused the video and taken a little bit of time to figure this out. And correlation coefficient is that R on your calculator when you do that stat edit calc stuff. And it measures how close the scatter points are when you do a scatter plot to, in this case, making an actual line itself. And if you remember, correlation coefficient runs between -1 through +1 and everywhere in between. So if the correlation coefficient, that R, is very close to -1, there is a strong negative correlation. And if it's very close to +1, there's a strong positive correlation. And if it's close to 0, well, that means that there really isn't too much correlation at all going on. Okay? Now, if you took the time to think about this, you would have realized that if you looked at the slope of this line, it's what kind of number? That's right, it's positive. So if there's a positive slope, it means there's a positive relationship, which means this is now out, and so is this. So that leaves you with a choice of 2 or 4. If it's equal to 0, that means there's absolutely no correlation whatsoever. And obviously, just from the problem itself, you should realize that it would be a correlation between a student's test scores and the success in college. So we know there is a relationship there, which would mean that 2 between 0 and +1 is the answer. Okay? Again, it's +1 because the slope is positive, therefore there is a positive relationship going on there. Okay? Hopefully you understand that. If you don't, you can let me know. So moving right along, you have two different types of models. You have linear models, and linear models are when your scatter points almost form an actual distinct line. Okay, that's a linear model. Exponential models, which we had discussed yesterday, have a little bit of a curvature to them. You can see that curve going on there. So linear models are in the form y equals mx plus b, because that's the form of a line. And exponential models are in the form y equals ab to the x power, because that's the equation of an exponential graph. Okay? So here's your directions. Some of you, if you have your own calculator, this is already on, because it should be on from when we did linear regression. typically it doesn't shut off unless you reset your calculator, okay? So you have two choices. You can go second 0, which is the catalog button, and you're going to put that diagnostic on. Or you can go to mode, then stat diagnostic, and then move it to on. What I mean by that is this is the screen. So you hit mode. This is the screen that comes up. You're going to come down to stat diagnostic right there and make sure it's on, hit enter, and then it's on, okay? So after you do that, this is your instructions. You're going to do stat edit. You're going to put your X values in L1, your Y values in L2. You're going to do stat calc and bring it down to exponential regression, which, just so you know, if you have the TI-84, you almost can't see it there. It's beneath 9. It is 0. And I'll show you what I mean in 1 second. And then you're going to hit enter and you'll see what happens, okay? So those are your steps, okay? You're going to do stat edit, enter your data. You're going to do stat calc, bring it to exponential regression, and bring it down to calculate. And I'll show you what I mean in a second. So here is your first question. The data collected by a biologist showing the growth of a colony of bacteria at the end of each hour are displayed on the table below. Write an exponential regression equation to model this data. Round all values to the nearest thousandth. Okay, so that's 3 decimal places you have to round to. So what I'd like you to do is I'd like you to pause the video again, and I'd like you to do stat edit, and this is going to be your L1, and this is going to be your L2. So what I mean by that is you're going to go stat edit, and you're going to go up to the header on that L1. You're going to hit clear. Then you're going to go up to L2, hit clear, and then you're going to enter your data into your X values into L1, and then your Y values into L2. So please pause the video at this point and plug that stuff in, and then we're going to take it from there. Okay, if you paused the video and plugged it in, you will see that this is your L1 right here, and this is your L2 right there. This is your X values and your Y values. At that point, you're going to do stat, and then you're going to bring it over to calc. So you're going to bring it over to where this calc right here is highlighted, and I already moved it. You have to move it. You'll see you only see up to 9. I moved it down so you could see up to 0. And 0 is exponential regression, okay? So you're going to hit that button, and then when you do, this is the screen that you get. Now, again, this is great because the top feature right here gives you the form of an exponential equation. It's y equals a times b to the x power. It gives you the a, it gives you the b. All you need to do is take these two values and plug them in. But where most people lose points is you have to remember the question told you to round it to the nearest thousand. So I need to be rounded to 3 decimal places to the nearest thousandth, okay? So your final answer should be here. If I were to round this, this is tenths, hundredths, thousandths. I have to look to the number to the right. If it's 5 or more, I'm going to round up. So my A here, rounded to the nearest thousandth, is 215.983 because I had to round up. My B to the nearest thousandth would be 1.65, and that last digit should in fact be, that is correct, 2, because this is not 5 or more, so I'm going to leave it flat. And then you just have to rewrite it. So your final answer here should be y is equal to 215.983 times 1.652 to the x power. And that is your final answer. Okay? Again, if you don't have a calculator, this is going to be very, very difficult for you to do, but we'll do the best that we can. All right? So now, let's take a second. We're going to look at this. It says the table below shows the number of new stores in a coffee shop chain that opened during the years 1986 through 1994. Using x equals 1 to represent the year 1986 and y to represent the number of new stores, write the exponential regression equation for this data. Round all values to the nearest thousandth. Okay, so again, that's going to be 3 decimal places. So it's telling you x equals 1. Is equal to 1986. So what that means is this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're not actually putting in 1986. 1986 becomes year 1. Okay? So again, you're going to pause the video. This is going to be your L1. This is going to be your L2, and see if you can come up with the answer. I'm actually going to stop the video right now and start up anew on a second one to make sure I can send it.